Ta-da!
Do you have Miss Campbell?
Use this inch for Quadratics.
Do you have Miss Campbell?
I'll also use the
Miss Campbell's necessary. Honestly, I don't think you could, but Miss Campbell's. It's easy.
Is anybody still working on the forms? Yes, no?
Maybe.
We still need that for a second? Okay, I see a couple still writing, no problemo. No problemo. Yo.
What's the last one where it's like X minus?
Q. I can't believe you can't tell. Come on, Alyssa. Jeez. Just kidding. Just kidding. Just kidding. Great. F of x equals negative 2 times x plus 3 squared plus 4. Okay, so what I'm going to tell you here, we're going to figure out a lot of things with this parabola. We're going to cover vertex, axis of symmetry, a minimum or a maximum. We're going to knock it all out of the park. We're not going to worry about transformations. That's what we did yesterday. So today we're only zoning in on one parabola. If you only have one, it doesn't transform because a transformation is a change, and so that means it changes from one to another. So we're not transforming, we're only on one. All right, we wrote down 3 forms, a vertex form, a standard form, and an intercept form. This is in vertex form. Vertex form had an A, an H, and a K, right? The A here is negative 2. See how that's in that spot? Now that tells me a couple of things. It's negative, so that tells me my parabola is going to open down. Okay, so it's going to, if we think about a U or a mountain, a U or an N, this one's going to be a mountain, this one's going to be an N. It's going to open down. Anytime your A is negative, your parabola is going to open down. Okay, now we're going to discover that that A, other than up and down, is also going to tell you if it gets wide or fat. That's the same thing, wide or narrow. Okay, fat or skinny, wide or narrow, and we'll figure that out as we go. So we know it's going to open down. That's my A. H and K tells me the vertex. Now, you got to be careful here, and it was written for you when you copied it down. The H is always the opposite sign. Okay, now look at where you wrote down vertex form. It said X minus H, didn't it? Okay, so that insinuates the opposite sign. Also, think about your transformations that we did yesterday and a couple of weeks ago. N with the X always went the opposite way of the sign, right? Remember that? Horizontal always went opposite. So, same deal here. Up and down, stuck on the N. That was positive, so this stayed positive. So I already know where the vertex of this parabola is going to be, and you do too. Now think about what vertex means. Parabola doesn't necessarily have a point, but it's going to have that middle place. Okay, so if I were to go left 3, I'm going to count on the red ones, 1, 2, 3, and up 4. what is my parabola going to do from that point based on my A? It's going to go down. So this point now is going to tell me that this parabola has a maximum. Okay, we're learning, it's not necessarily a new word, but it's a new term. If my parabola goes down, it has a maximum because it can't go any higher than that, right? Some of y'all might need to make a note here. If we have a normal U parabola, it can't go any lower than that, so it has a minimal. Okay? Now you're going to get your minimum or your maximum value from the y of your vertex. So on this parabola here, we know it's going to have a maximum, right? We've discovered that. Its maximum is going to be 4. So I can write this parabola has a maximum at y equals 4. It's not going to go any higher than y equals 4. Okay, now check this out. I know that this parabola is going to have an axis of symmetry at x equals -3. Okay, let's digest where I got that from. What does an axis of symmetry mean?
It's like in the middle, so you fold it.
Okay, very good, Lane and Joe. That's that fold line that I've been hinting about all along. Axis of symmetry is where you can fold it and it's perfect on itself, right? So that's got to be right in the middle of the parabola. Notice our x-coordinate of our vertex is your axis of symmetry every time, because that's going to be in the middle. So you're going to see me a lot of times as I'm drawing this, draw a little dotted line through that. That's going to be that fold line that I have. Okay, but this is a quadratic because it's squared, and we learned that a couple of weeks ago. Anytime your highest power is a 2, it's going to be a quadratic. This is a quadratic. It's going to make a parabola, and right now I've only got 1 point. So I've got to find another point somewhere on my parabola. Any guesses on how I can do that? Very good. And that's exactly what we're going to do, what Lady Jo said. I'm going to pick any x I want to except for -3. Because what would I get if I plug -3 in there and solve? Right, I already have that point. So I got to pick any x I want other than -3. Now, there's no right or wrong on this. But remember, whatever you plug in, you've got a graph. So I wouldn't want to say, well, let's plug in 99. Because then you got to graph 99. Right? I try to pick something close to the point I already have. You're going to learn from me throughout the year that 0 is a magic number. Because zeros are easy to work with in your head because they're nothing. But this is a case where I'm probably not going to plug 0 in. It's not too far away, but that's just going to make my parabola be humongo, and I don't feel like drawing a humongo parabola right now. So since this is at -3, how about I do -2 or -1? Stay close over there in the ballpark. Okay, do you got a preference, anybody? -2. So we're going to plug in -2 where the x is, and we're going to work that out to get the y. Okay, come over here and do this. So I've got -2 times -2 plus 3 squared plus 4. I just plugged it in where the x is. Now you got to follow your order of operations. Parentheses first. -2 plus 3 is 1. 1 squared is 1. So I've got -2 times 1 plus 4. -2 times 1. -2 plus 4. So I should be able to go left 2 and up 2 and be on that parabola, true? So from the origin, 1, 2, 1, 2. All right. Anytime you connect 2 points, you can make a line. I need to make a parabola. Do I got to plug in another point? She's right. No, I don't. I could. But since I've got that magic fold line there, whatever happens on the right side of the fold line, doesn't it have to happen on the left side also? So can't I just do some magic kindergarten counting here and say, well, if this is one away from the fold line, don't I have to have one that's one away on the other side? That's why I draw that dotted line, for that purpose right there, because I'm a good counter. Aren't you glad your math teacher's a good counter? It'd be bad if they weren't. Sometimes I gotta count on my fingers though. Alright, so I got 3 points. I got a parabola. Draw that thing. Try not to make it with a U. Rewind. Try not to make it with a V. Try to round it up there some. That's it. We only had to do math one time. We were given the vertex. We just had to learn how to find it. We were given it. We did the math over there by Paul to find 1 point. And then we just folded and counted to get the other point. Not very difficult, right? Pretty good stuff. Alright, I'm going to let you digest that. Get that finished in your note. I'm going to write another one that you're going to just try right there at your tables in your notes. Vertex, axis of symmetry, min or max. You got all those things? Are you alright on those? Whoop whoop! So this one says f of x equals 0.5 times x plus 4 squared minus 2. Alright, what I want you to try right now on your own note paper is to get a graph of it and be able to identify the vertex, the axis of symmetry. Is it a minimum or a maximum? And what is the minimum or the maximum? So give all that a whirl. I'll be listening and watching. If you got it, shout it to see if your neighbor's got it too. It's always going to, since it's a minus up there, it's always going to be the opposite sign with the x.
Oh.
The K part, Riley, gets the right sign. It is what it is.
Okay.
But the H always gets the opposite. Yo, yo. Yeah. It doesn't have to be perfect, but yeah. We're going to do those other forms too, but it is just parabolas to do that.
This whole unit's just gonna be correct.
You're still going and you're doing fabulous, but I just want to make sure you're on the right road. So let me at least make sure everybody's got the correct vertex before I let you finish. What did everybody get for the vertex? Okay, we got the opposite of this sign, so we got a -4. This sign is right. You keep that sign like it is. Good job. So everybody's got the good vertex. Okay. My other questions that I'm going to ask you in a second come from the vertex, right? Did we notice that on the first problem we did together? Is this parabola going to have a minimum or a maximum? It's going to have a minimum. How could I know that for sure? Just by looking.
Not a negative sign in front of your A.
Very good. My A was a 0.5, and that was a positive, so that means it opens up. When it opens up, it's got a minimum. What is my minimum? How low does it go? How low is that? -2. So that's low up and down. So that's my Y equals. Where did I draw that dotted line? That's my axis of symmetry. I went over to the left 4, so it's at -4. Okay? Those two answers came straight from your vertex. So last thing I got to do is I got to do math one time to find a point to plot. So did anybody got one they want me to do that you did? -3. Riley was fast on that. So I'm going to do -3. Now, what if somebody did a different point? Right. Because just like you learned about in algebra, a line goes forever in both directions. Those parabolas keep going forever in whichever direction they're going. So while me and Riley may do -3, but Garrett may do 0, our parabola would still hit his point. Right? Okay, so let me scroll so I can see the equation and we'll plug that -3 in. Got 0.5 times -3 plus 4 squared minus 2. Alright, so I'm going to have a fraction here to deal with, I see, but that's okay. -3 plus 4 is 1. 1 squared is 1. A half times 1 is a half. And then a half minus 2 is -1.5. Okay, so I've got to go left 3 and down 1.5. So 1, 2, 3, 1.5. Now, I got better toys than you because I've got the nice big graph paper that I counted far apart, so I had nice pretty halves marked out on your paper. You're just giving me an estimate there, somewhere between -1 and -2, as close to a half as you can. But now that is If I fold on my hot dog fold here, I'm 1 away. So I've got to be 1 away on the other side. Now, I told you a second ago we were going to talk about getting wide and narrow, and that's also based on the A. So while you had those two graphs right there on your paper, I want you to teach me now. How does this one, wide or narrow, compare to the first one that I did with you? Is this one more wide or more narrow? It's a lot more wide. What was our A here?
It was 0.5.
It was 0.5. And if I make that connection to what we've already learned, 0.5 is smaller than 1, isn't it? So when my A is smaller than 1, my graph is going to become more wide. On the first one we did together, our A was 2, which is bigger than 1. That graph became more narrow, didn't it? So I might be able to say here, when my A is less than 1, my graph is more wide. When my A is greater than 1, my parabola is more narrow. Good job. Seems to always be a question about that on test time. Everybody all right? Got what we need, at least on the smartboard, so I can get the next one ready? All right. So that dude says f of x is equal to 3x squared minus 6x plus 1. Does that look like vertex form that we just did?
No.
I don't think so either. A little hint, vertex form will always have one parenthesis that's squared. We got something squared here, which means it's a parabola, but we don't have that one parenthesis squared. It's not in vertex form. Intercept form will have those two parentheses. I don't see two parentheses. So the only other choice is standard form. Does this look like standard form?
Yes.
Yep, I got ax squared, bx, c. So this is standard form. Standard form is pretty common. First place to start with standard form is always going to be that little shortcut that I wrote for you. X equals negative b over 2a. X, that gives you the axis of symmetry. So that's axis of symmetry is the first thing we're going to find, and then you use that to finish your vertex out. So we're going to start here. X equals negative b over 2a. So x equals, and I'm going to write that negative every time. What's my b?
Negative.
Bradley's got negative 6, right? You got to, if it's got a minus sign in front of it, you got to take that negative. So I got a negative 6. What's my a? 3. So I got 2 times 3. It's always 2 times a every time. Make sure you got that shortcut written down. Okay, now what's going to happen here with my negative and negative? Negative by negative is a positive, so I don't even got to worry about that anymore. So won't this just be 6 divided by 6?
Yeah.
Okay, so you know your axis of symmetry. So I can come over to positive 1,
3 times by 2.
and there's my dotted line.
That's just part of it. That's just part of it.
Yeah, the 2 is always going to be there.
Oh,
Okay, but in terms of vertex, I don't know everything yet. I know my 1.
just plug in one.
Good. So to find that y, I now got to do a little bit more math than I did on the other kind of problem, because I got to plug that 1 in for both of those x's to solve for my y. Okay, so that's going to be 3 times 1 squared minus 6 times 1. I just plug those once. See where we are? Just plug those in. And you're like, oh, crud, that's a lot of math. Well, it's ones. It's not like it's any rocket science or anything. So this 1 squared is 1 times 3 is 3. 6 times 1 is 6. It's negative 3 plus 1 is negative 2. Good. So we know our vertex is at 1, -2. So it's down there for me. Okay. Do you have a guess on this? Granny Joe said it's going to have a min, and I say 2 thumbs up. How do we know when it's in standard form? It's the same way. You still look at the A. Even though the equation started different, it's still from the A. The A's positive, so it's opening up. You get to do touchdown signal. When the A's positive, it opens up. If it opens up, it's got a min. So even though my vertex on my graph is way down here at the bottom, that's okay, because I know it's going to open up from there. Okay, so I just need to plug in another point somewhere close. This is where I'm going to grab hold to my favorite 0. So I'm going to plug a 0 in, and you're going to love this as much as I do. Check this out. When you plug a 0 in for both of those x's, that's 0 now, right? That's 0 now, right? So all you got left is 1. Okay? So over 0, up 1. Now you get to do your kindergarten counting and match that on the other side. Bam, bam. I got to scoot it up to see my vertex down yonder. That's pretty skinny. Should it have been? My A was 3. 3 is bigger than 1. I should have been expecting narrow. Hey, life's good in the hood. So, you making fun of me?
No.
Okay.
No, I was making fun.
Oh. She didn't make fun of you. It's better.
Not really. Yeah, that's nothing about.
Alright, so maybe a step more of math on that one, because when you had to do the shortcut to get the x, and then you had to plug it back in to complete the vertex, so maybe a step more of math, but it was not any rocket science, right? I mean, yep, pretty. Let me let you look at one of those now and give it a whirl. X equals x squared plus 2x minus 1. I want you to try and do everything we just did. Try to get a graph. Well, you got to have a vertex, an axis of symmetry, min and max, and then a graph. So all the stuff that we just did. Got to start off, it's in standard form. You got to recognize that. So start off with that little shortcut, negative b over 2a. Good point. So if there's no number there, what's an understood? You guys see. Okay, all I did was set up my shortcut for you because I just want to make sure everybody stays on the correct road. Like Riley told me, there's no A that's written. So how many x squareds are there if there's no number in front of it? It's an understood 1. So you're using a 1 in your A spot. So negative, and your B is 2 over 2A. Right. So it will be like what's the parent? It wouldn't be more wide. Right. Your X is not correct though. Because when you divide here, that's like 2 divided by 2, right? So that's going to change your Y when you plug that back in. Hey, just because you're too smart doesn't mean you can distract these people that are trying. I know.
Okay, question. Before okay, this one, do you have to flip it whenever you plug it in, or do you just leave it?
You just leave it because that's a tricky question. Because some people, when they go to plug it in, they're going to say, well, I got to do, since the formula says negative B over 2A, they're going to plug the opposite in and then not put that negative out there. But I put the negative out there and then keep it like it is. Either one will work. You just need to sell out on whichever one you're going to do so you're not like going wishy-washy and getting mixed up.
Okay.
Does that kind of make a little sense? What's the matter?
I'm just lost.
Make sure when you square a negative in your calculator, you put it in parentheses because it does it. If you don't, it squares the 1 and then makes it a negative. So that's your other part of your vertex.
Coach Wright?
Yes.
Can you send Riley Carper to the office?
She's not here today.
Thank you.
I'm not going for it. Yes. No, that's your X is not right. Because remember it's negative B over 2A. You left the negative off of that. Well, yeah, sorry. Your Y is not right. What you need to do, did you do that in calculator? Yeah. When you plug and do a negative squared, you got to put it in parentheses or it has it wrong. So go back and see if you can get that again. Same thing, no. When you do a negative squared, you got to put it in parentheses because it does it wrong if you don't. Okay. People, sorry, Tori, I forgot. Alright, so now is when you get to pick another point. So you pick any X you want. That'd be really easy. Zero in for both of those X's. They'll give you another point to play. Alright, a common mistake I've seen, most everybody got the X right. Everybody get your axis of symmetry at -1. Most everybody had that, but then when they plugged it back in, they didn't get the same Y as me. My Y should be -2. The mistake that is happening is y'all are just typing that string in the calculator, If you do a negative squared in your calculator, you have to put it in parentheses. If you don't, it does the 1 squared first and then makes it a negative. But you know that a negative times a negative is a positive. But to make your calculator talk right, you've got to put it in parentheses. Okay? So you should get a vertex of -1, -2. Let me see what we got going. -1 squared is 1.
Yeah.
Right here, positive times a negative is a negative. Oh, you got that.
Yeah,
So 1 plus -2.
It's like
Oh, it's because I put it in.
Glad I could help. All right, so I'm going to go left 1 and down 2. So that's my axis of symmetry at x equals -2. Does this have a minimum or a maximum? My x is positive, so it's opening up. So it's got a minimum at y equals whatever your y is, -2. So do you see now how if you get the vertex wrong, you're going to get all those answers wrong? Because they just come straight from the vertex. So be super duper careful.
I thought mine was
I got -2 for y.
I thought X was -1.
It is.
Oh.
I wrote it. I see what you're saying now. I see. I wrote the y twice up there. There you go. Is that better? Is that what y'all were asking about? Good. All right. Now, and this is where some people got. I was talking to Tori. We got here. Where do we go next? We got to. Well, we know it's gonna. We just said that it's gonna be a min,
Plug in.
right? Like we just need to plug in another point. Don't put it away. 0 on this one. Like. Thank you. I'm sorry. It was on my tongue. Like 0, like Chloe said on this one, would be super easy. Because if you plug a 0 in for x, 0 squared is 0. 2 times 0 is 0. So all you've got left is a -1. 0, -1. And now you just get to count. Jump that dude over. Scoot it up so I can draw my pretty parabola. Now, one thing that Lainey asked about, or A was 1. So what does that mean about wide or narrow? It's the same width as the parent function. It didn't get wider than the parent function. It didn't get more narrow. It's just normal, same width. Good job. Okay? Alright, last one I'm going to show you today is the intercept form. There's not near the frequency of intercepts that you'll see, but you might see one occasionally. They're easy. Maybe that's why you don't see them as much. Alright, so that says f of x equals -2 times x plus 3 times x minus 1. Okay, it's clue that it's an intercept form is it's got 2 parentheses. Now, every year when we get to intercept form, someone will say, well, we're supposed to be doing quadratics, and a quadratic squared, I don't see a squared up there. The squared is in disguise. It's very good. If I were to go back and start multiplying this thing out, what's an x times an x? An x squared. So I do have a squared, it's just in disguise. Okay? So it still is a quadratic. I don't want to multiply it out, because then it will be in standard form, and then I have to use that shortcut. I can graph it easier with the stuff it's given me. Okay? From intercept form, we got an intercept at the opposite sign of our p. Remember it said x minus p? You with me? So that would be -3, 0. Opposite sign of my q. +1, 0. Okay, so check this out. negative 1, 2, 3, 0, 1, 0. Okay? Now, deep thoughts right here. Come on. How do you think I'm going to find the axis of symmetry with just those 2 points? Oh, it's going to be halfway between those, right? Because that axis of symmetry's got to be in the middle. So I got to figure out what's halfway between these. And that's another easy kindergarten counting. I'm putting my fingers here and I can just start counting. 1, ding, 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 right? So my axis of symmetry has to be right there at x equals negative 1. And I just got that by counting because it's got to be in the middle. Okay? But I don't know how high or how low I got to go. So what can I do to figure out how low? I got to plug this negative 1 in for both of those and solve. So I'm going to negative 2 times negative 1 plus 3 times negative 1 minus 1. So that is 2. That is negative 2. 2 times 2 is 4 times 2 is 8. Right? Negative times negative is positive. So it's got to be at up 8. 1, 2, 3. So that's going to be off my graph. Y'all all right with that? If I just estimate that goes off of my graph up there. So it's going to be way up there. Now, looking at these 2 points down there, if I got this dude way up there, that's obviously one of these. Does that make sense? What's my A? It's negative, so it's supposed to be one of these, right? So I'm good on that. So I'm going to try to draw this ginormous thing. That's it.
Wait, what was it? It was 8?
Yes. Yes. Is that what you got?
Yes.
Good. Good in the hood. All right. It's got a max at 8. Y equals 8. What do you think? I think if I maybe did a couple of graphs with you at the beginning tomorrow and then gave you some to do on your own, you could do it? Yep. That'll be the plan, Stan.